Hi, my name is Damien Dooley, and as just introduced, I'm here to talk about FoodOn and the OBO Foundry family of ontologies. I work out of the Public Health Bioinformatics group at Simon Fraser University, and we are a team involved in public health and One Health initiatives. A number of us are in the ontology world, listed there on the slide, and we're proud to have the support of Genome Canada, the US Department of Agriculture Research Service, and affiliation with the University of British Columbia as well. So I'm here to talk about why we came to the food ontology problem, and it's summarized with this example of a 2011 E. coli epidemic that started in Germany. It took 2 months to resolve. 4,000 people fell ill, 47 fatalities, 16 countries involved in the outbreak and investigation, and 70 companies. It was a real problem because the data systems just weren't there to do traceability, and so people were wondering whether it was cucumbers or tomatoes, leafy vegetables. Spain was falsely implicated for a period of a few weeks, and embargoes were triggered. Over 200 million euros cost. So we know the economic impact of foodborne disease, in this case leading back to a single shipment of fenugreek seeds. So that problem of traceability has been attacked, of course, by the blockchain folks and big companies and little companies offering systems that demonstrate product traceability in partnership with the various companies involved in their production and distribution. And this is happening in the food area, as I've listed a number of organizations, companies there doing this. The traceability is organized by product identifiers or QR codes, and security is being provided at different levels for this information that is accumulated along the supply chain. The knowledge is also being packed in, other aspects of knowledge, shelf life, spoilage, authenticity of the product, the rearing context, organic material, etc. And the question, though, is whether this extra knowledge is actually queryable and who controls the vocabulary that this knowledge is being encoded in. And that's where knowledge graphs come into play and ontologies. But I'll just emphasize that it's not just the food chain actors, food distribution actors that are interested in the information that's being collected. Epidemiology, Centers for Disease Control are equally interested, especially for trace forward and trace back. And they have their own databases that are often using a number of the similar terms. So whether it's CDC Atlanta or British Columbia CDC or the WHO, we're seeing this terminology being used for many other agencies, and it would be great to harmonize it all so that they could take advantage of the blockchain traceability and not have to write interfaces to their own databases. So, a solution that involves knowledge graphs and the global vocabulary is one that would avoid lock-in to a particular supplier's vocabulary. But this means that companies and agencies have to learn how to externalize the vocabulary that is being used in their databases. And so they have to get used to the idea that the intellectual property that they prize for their unique business model is actually one layer up above the vocabulary, which is globally shared and referenced. So this is all happening in the context of an emerging domain of vocabulary standards. And of course, standards haven't just been invented in the ontology world, but I'm going to talk a bit about the OBO Foundry Encyclopedia of Ontologies as a wonderful approach to standardizing language and FoodOn more specifically. So the OBO Foundry family of ontologies is a collection of ontologies that all ascribe to a particular curation standard. And this involves over 50 ontologies involving terms for chemistry, disease, genomics, medical studies, anatomy, and FoodOn, our own ontology, as I'll show in a moment, relies heavily on a number of these. They're all designed not to reuse, they're all designed to reuse each other's terms rather than reinventing terms and causing confusion about which terms might map over. So, and the other thing to say is that each of these ontologies has a curation community. It's usually much more than just one agency involved in supporting the ontology, and that allows for a degree of expertise and harmonization of expertise across agencies, and more of a trust that the resources, ontology resources, will continue into the future. So here's a peek at the FoodOn ecosystem of ontologies. Here we've got a rough illustration of agricultural products coming from either the wild or from agricultural context that are harvested and turned into food products and that end up in consumers' tummies. And there's a spread of ontologies that are involved all the way along this descriptive chain, and a number of those are used by FoodOn, and a number are used by other ontologies that have all cropped up around FoodOn and other OBO Foundry ontologies in the last year. So on the left, we've got Envo and Agro, Environment Ontology, Agronomy Ontology. We've got NCBI Taxon for taxonomy, CHEBI for chemistry, CDNO, Crop Dietary Nutrition Ontology, a number of anatomy ontologies. And then over on the right, at the consumer end, we've got analysis of chemistry, chemicals, times across products with food effects, dietary studies, genomic epidemiology around particular pathogens, foodborne pathogens, and the diseases. So this illustrates quite a conjunction of ontologies together, working to provide the vocabulary, not just for one particular use, but for many uses. So in FoodOn, if you dive inside the hood of FoodOn, you'll see that it's actually made up of facets, different ways of describing a product, whether it's a dish on a plate or inside a package of some kind. Packaging, consumer group, part of organism, the production environment, the processes used to create it, the kind of qualities it might have. And so you can describe as a bag of terms any ontology, any food product as a combination of these different facet terms. Organic mashed carrot baby food jarred has got a jar for packaging. Baby as food consumer. Part of organism that it's got is a root, and it's from a carrot plant, and so on. So the thing about ontologies is they're not just bag of terms. The other thing they bring to the table is relationships, more structured data. And this will, I think, eventually show up in knowledge graphs. The standardization will not just be about the categorical and numeric variables, the columns and measurables themselves. It will also extend to little miniature standards around how to measure things and how to report them. So here we've got a food product that has maybe an input or an output to food transformation processes. We've got, it's surrounded by some food packaging. It's adjacent to food product contact service, a tabletop or some piece of machinery in its history, and has different kinds of qualities. So again, organic mashed carrot baby food will have a quality of being strained, will have baby as food consumer, and a jar as surrounded by. So these relations are now attaching different terms. The way that knowledge graphs will start using this information is by having particular instances of food products or shipments of product having qualities as they go through time, and those qualities will come from controlled vocabularies that we can describe. As well, there's a whole hierarchy of terminology that ends up being combined so that you can describe things like Fuji apples with their skin raw as a precomposed term, a term that exists and you can reference in the database as a category. And this is just an example of another database of Agricultural Research Service, ARS Foods, and their foundation database that's been tested for nutrient content being categorized within a FoodOn class of food. So in the development of FoodOn, we've got about 676 chemical food components to describe nutrients and additives, over 3,700 organism sources for food items, anatomical part references for food, and then a chunk of about 10,000 food products that are single or multi-ingredient foods. Multi-component food products are a separate category. There are over 900. A variety of food processes and third-party agency categorizations that will be mapped as part of the upcoming work to food products native to FoodOn. So CDNO, Crop Dietary Nutrition Ontology, will actually be providing us with the hierarchy of nutrients that the USDA and InFoods use. That's an upcoming project. We're in the process of robotizing or creating strong patterns for organism and part, which is the basis of all food products, the raw ingredients. Adding and enhancing Wikipedia definitions so that there's a synchronization between FoodOn, most foods, and the ability to go check out what Wikipedia has curated about such a food. And we're working on enhancing the process branch and mapping those agency foods over from EFSA, for example. And that's the end of my short presentation here. So thanks very much for your attention.